Hello, and welcome to Putting Your Head in the Cloud, a beginner's guide to cloud computing and Azure SQL database. This is the second release of this presentation, which now demonstrates the new Azure Portal that became standard in December 2015. My name is David Postlethwaite. I'm a database administrator for Liverpool, Victoria, one of the largest financial services companies in the UK with over 5 million customers. I've been a SQL DBA for the last 7 years, and I currently manage SQL Oracle instances, including database, analysis services, integration services, and reporting services. Before becoming a DBA, I was a developer using .NET, SQL, Access, FoxPro, and Oracle. And way back in time, I used to be a Windows and NetWare administrator. I contribute to the blog on gethanellis.com, and everything you're going to hear today has appeared in that blog. So if you don't want to make notes, check out Gethin's website. If you want to contact me, my email address is on the screen. In recent years, cloud computing has become the hot topic in the IT industry, and although Microsoft Azure and the cloud has now started to become mainstream, for many of us it's still a mystery. I started looking at Microsoft Azure a couple of years ago as a possible solution for a project at work, and I soon realised that neither I nor my colleagues knew that much about cloud computing. So I decided to put my newfound knowledge into a presentation for work and for here as well. Today we will look at cloud computing, what it is, how it came about, the types of cloud available, and the advantages and disadvantages of using the cloud. We'll then take a look at Microsoft Azure and a specifically SQL Azure database to see how to create and use SQL databases in the cloud. Everything in this session and a whole load more on Azure SQL database is available in a free ebook. This is the second edition, updated to reflect changes to the Azure Portal since I first wrote it, and you can get this for free by signing up on the gethanellis.com website. Just as a matter of interest, I'm sure a lot of you here are already using cloud. Maybe you don't think you are using cloud for personal or business use, but maybe I may be able to help you come up with a different answer to that. So why has the cloud become such a big thing in the last few years? Well, IT infrastructure has grown enormously in the last 25 years. When I started in IT, we had big standalone PCs that took up most of the desk. Software was installed on each computer, and the only way we could communicate was by floppy disk. Data transfer was at walking speed, and wide area networks worked at the speed of the postman. In contrast, today all our computers are connected within the office and with the rest of the world, and we do everything using a computer, tablet or smartphone. In business, we're constantly having to buy bigger and faster hardware, upgrading old kit, patching operating systems, and installing the latest software. We've built our own data centers full of servers, and we will often have a disaster recovery data center full of more servers waiting idly for something to go wrong. We're having to manage our backups, our mirroring, and our clustering in these data centers that require 24-hour care. Running and maintaining our business infrastructure has become very expensive, and our bosses want to save costs, and they're asking, why do we need to buy and maintain our own servers and spend our lives upgrading and fixing them? Why do we need an expensive DR site that sits idle most of the time? Why can't I just rent a file server or a database server or a web server or even an application and pay someone else to manage it for me? And this is where the cloud comes in. So what is cloud computing? Well, this is a definition I found on the internet. The practice of using a network of remote servers hosted on the internet to store, manage and process data, rather than a local server or a personal computer. In a nutshell, cloud computing is putting all or some of your data center into a shared resource on the internet rather than running it from your own premises. The word cloud is often used as another name for the internet, So the phrase cloud computing really means internet-based computing, where different services such as servers, storage and applications are delivered to your organization's computers and devices through the internet. You may already be using cloud services. For example, email. If you're using Gmail, Hotmail, Microsoft Mail, in fact any webmail where the mail server is not on your premises, this could be classed as using the cloud. We've been doing that for years before the term cloud computing was invented. We've been doing that for years long before the term cloud computing was invented. Cloud storage. Lots of us are using cloud storage such as Microsoft OneDrive or Google Drive to back up our data on a hard disk to the internet. You can automatically sync your local data to the cloud disk so that you never lose it. You can access your cloud storage from other devices so you're not tied to just one PC or even just one location. There are masses of software that you can run directly on a website without having to download and install it on your PC. For example, Office 365, Skype, the web, Photoshop, Visual Studio Online. I'm sure everyone here has used an application on the web, even if it's just an online dictionary or language translator, a foreign exchange calculator, or online banking. If the application runs on a website rather than on an application installed on your PC, then it can be considered as part of the cloud. Server hosting is what we traditionally think of as cloud computing, running databases or servers from a shared data center on the internet. All the big players, Microsoft, Amazon, Google, even Oracle now, are offering this, as well as many small suppliers. So maybe you didn't think beforehand that you were using the cloud, but maybe now you might think that you already are there. There are three main service models in the cloud, and you'll see these buzzwords being used a lot in cloud discussions. And these are Infrastructure as a Service, or IaaS, Platform as a Service, or PaaS, and Software as a Service, SaaS. Now, to get a better understanding of what these mean, take a look at this diagram, which shows the typical layers of an IT solution, starting from networking through storage, servers, virtualization, all the way up to the application tier. Now, infrastructure as a service. Think of infrastructure as a service as hardware to rent. Instead of purchasing network equipment, storage space, or servers, use the cloud provider's infrastructure. This means the cloud provider owns and maintains the housing, running and maintaining of all the hardware, not you. You will need to install an operating system and database software, but you don't have to worry about maintaining the hardware, and the cloud provider will have mechanisms in place to ensure that your hardware continues to work in the event of a failure. Platform as a service. Think of this as servers to rent. Here the cloud provider supplies you with hardware, operating system and database server. You simply place your data in the database server and connect your application to it. You don't have to worry about patching, upgrades, failover or backups. The cloud provider will manage all of that for you. With both IaaS and PaaS, you have the flexibility to use more or less storage or processing power as and when you require it. This is attractive to businesses which might otherwise have to maintain large amounts of storage space just for occasional peak times. With software as a service, we go the whole way and simply rent applications over the internet from the vendor. We don't have to worry about hardware, operating systems or software maintenance. Generally, you only have to pay for the time that you use the application on a pay-as-you-go basis, which is why this is sometimes called software on demand. As well as removing the need to buy and install and manage software on your computer, it also has the advantage that the software can be accessible from anywhere with an internet connection. So why would you want to use the cloud? Quick setup. You can provision a fully functioning database server in just a few minutes, whereas on your premises it can take weeks to order hardware, then build and connect a new server into your network. Scalability. With the cloud, you have access to unlimited capacity. You can increase the power and size of your server in times of high demand and then reduce it when the demand drops. The classic example often quoted is that of a ticket agency. For most of the year, traffic's fairly steady, but when the tickets for a major artist go on sale, then demand ramps up for a few days. With a cloud service, you can simply increase the power and size of your system for those few days, then when sales are complete, drop the power back down again. Whereas if it was all in your own data center, you might have to buy and maintain all that extra power and storage all year round. Cost efficient. Aside from storage and infrastructure costs, you might no longer have to update and manage software or applications, patch servers. As we've already said, you only pay for what you use. Most cloud providers offer comprehensive backup and recovery capabilities. Backups happen automatically for you, and you don't need to check every morning that it worked. They'll have huge redundancy built into their data center and at least one other data center in another city or even another country to ensure the system is always available. Because it's all on the internet, you can access it from anywhere with an internet connection. It can also be thought of as environmentally friendly. The cloud provider packs a lot of computing power into their data centers, which are much more power efficient than your own data center will ever be. The servers are utilized to the maximum, whereas if your company is anything like mine, you have plenty of servers that are barely ticking over. Innovation. If you have an idea and want to give it a try, spin up a new server or a database in the cloud in a few minutes, test out your idea, and when you finish, just delete the server. You'll only pay for the time you had it running. Just think how long it would take to get a server built and available in your office. Security. Most cloud companies use industrial level security software and practices which are probably more secure and better managed than you can do in your own data center, which makes it harder for hackers to get to your data. That's harder, but not impossible. What are the disadvantages of the cloud? Why wouldn't you want to use it? Security and privacy again. Security and privacy are the two main concerns that when looking at the cloud. By outsourcing your IT infrastructure, you are placing your data that might be sensitive and confidential on servers that are not owned by you. You have to rely on the provider to maintain the security of that data, and there could be severe repercussions for you if your data was leaked or lost. Dependency is one of the major drawbacks of cloud computing. Once you've gone with one cloud vendor, it's difficult to migrate to another because of the huge migration involved, data migration involved. Since the servers run on a remote virtual environment, you've less control over the hardware and the software. For instance, the cloud provider may force upgrades onto you, which may require a lot of rework to your applications. Since everything is now on the internet, the risk of the entire environment being vulnerable to hackers or denial of service attacks is always there. Outage and downtime are two of the most important aspects that even the best cloud provider can't completely guarantee. Also, with the whole setup being on the internet, if your office loses its internet connection, then you can't work. On the other hand, if you host everything on premises and your data center loses its internet connection, then your customers may not be able to get to you to buy your products. Government interference. Microsoft Azure is compliant with EU data protection laws, so data in the European data centers will always stay in Europe. However, Microsoft and others have stated that under the USA Patriot Act, the US government can request access to their data even if the data resides outside the USA, bypassing EU laws. Microsoft are currently fighting a case with the US authorities who are trying to get access to emails held in the Ireland data center. You will have to weigh up the advantages and disadvantages and decide what is best for your company. So let's take a look at Microsoft's cloud offering. Originally called Windows Azure, it was renamed in March 2014 to Microsoft Azure to reflect Microsoft now offering more than just Windows-based services. Azure is available in 141 countries, including China, and supports 10 languages and 24 currencies. Microsoft has divided the world into regions. There are currently 22 regions, with more due to come online in Canada, Germany and the UK soon. There are currently 2 regions in Europe: North Europe in Dublin in Ireland, and West Europe in Amsterdam in the Netherlands, even though Dublin is further west than Amsterdam. You can choose to place your cloud services in any data center in the world, but putting your data or applications on the other side of the world may affect your customers' performance if they are all based in Europe. You'll see there are no data centers in Africa. South Africa was allowed to start using Azure last year, but their nearest data center is so far away that performance is almost unusable. Microsoft has gone into the cloud in a big way. They have spent billions of dollars on it. As you can see from these photos, the Microsoft Azure data centers are huge. The Dublin data center, which was the first mega data center built outside the USA, is now 581,000 square feet. That's equivalent to 4 football pitches. The Chicago data center, one of the largest, is 700,000 square feet. And in 2014, Microsoft announced plans to spend $1 billion on a new data center in Iowa, in the United States, that will be more than 1.2 million square feet. So you can see that these places are huge. In the data center, the servers are housed in standard 40-foot shipping containers. Each container holds anywhere between 1,800 and 2,500 servers. The shipping containers arrive fully built, so all the on-site engineers have to do is plug them in using a standard connector that provides power, calling and network access. The servers remain inside their shipping containers inside the facilities, where they're placed side by side and stacked 2 high. The data center has room for over 100 containers, giving a capacity of over 220,000 servers. A new container arriving at the data center can be installed in just a few hours. That's 2,500 servers installed and ready in less than a day. How long does it take your company to install 1 server ready for use? One of the major benefits of cloud data centers is energy consumption. This is measured as power usage effectiveness, or PUE, a measure of the amount of energy required to cool a computer compared to the amount of energy needed to run the computer. The data center for your company probably has a PUE of about 2. In other words, it takes as much energy to cool your data center as it does to run the computers within it. The Dublin data center has a PUE of 1.25, and it achieves this by using a cooling system that uses outside air to cool the data center, and a server design that allows the servers to operate at a much warmer temperature than normal. Microsoft says it runs the server rooms at temperatures of up to 35 Celsius, much warmer than most data centers, which typically run at around 21 Celsius. So let's flip over and have a look at Microsoft Azure. The URL for Microsoft Azure is azure.microsoft.com, and as you can see from this site, Microsoft are pushing hard for you to try it. There are several free trial links on this screen. There's also webinars, videos, blogs, information on the popular products, examples of how they're using it, and even Real Madrid are in on the act, so that must make it good. To log on, we simply click on My Account, and then we can click on the Azure Portal. If you have an MSDN subscription, then you have between 45 and 100 euros per month credit on Azure. If you use all your credit, your service will be disabled for that month, or you can opt to pay for the extra usage. If you don't have an MSDN account, you can create a trial account, which does require a credit card number for ID purposes, which you can try for a month. Microsoft say they won't take any money at the end of the trial. They'll just disable your services until you choose to start paying. you do require a Microsoft Live account to use Azure. Now this is the portal. This is what Microsoft calls its website for managing all the Azure services. This is the new portal. It came live in December 2015 and consists of tiles, blades and windows, which do tend to pop up as you're using them, and it can for a while be quite confusing to try and get the hang of it. The old portal was a lot simpler, a lot low tech, using tabs and drop down menus, and many administrators prefer it just because it's easier to use. Just to show, this is what the old portal looks like, or what is now called the classic portal. But since Microsoft are now pushing everything into this portal, this is what we are going to demonstrate today. Many features are now being disabled in the old portal, and any new features are only being added into the new portal. But slightly confusingly, there are some features which are still only available in the old portal and haven't made it in here yet, one of which is in the SQL Server side. Microsoft obviously offer more than just SQL databases. You can have application servers, virtual machines, you can create storage accounts for holding data and tables, you can create automation accounts, mobile services, schedulers, you can link your Active Directory. There is a whole list of things here in the browse, many of which I don't know what they are, but there are plenty. Microsoft offers a huge amount of services available for you, covering everything you could ever dream of. Now we're going to concentrate on SQL databases, so I'm going to click on SQL databases here. And here we can see a list of the SQL databases that I have already created in Azure. Azure SQL Database is an example of platform as a service. We don't have to build a Windows server or install SQL Server or configure the SQL instances. We don't have to worry about software upgrades or the disk configuration. Microsoft have done all of that for us. Azure SQL Database simply provides us with a platform where we can place our data. Once we've created our database, we can connect to it from our PC using Management Studio, or connect our applications straight to the database. So if we want to create a new database, we simply click on Add, and we have to answer a few simple questions. First of all, we need to give the database a name, so we'll call it DB1, and we'll check that it's correct. I only have one subscription, so that's where we will be placing our new database. A resource group is simply an area that we can group our services together, either for management, either to make it easier to manage, or maybe for billing purposes. We can select the source of our database. We can create a blank, empty database with no tables or anything. We can select a sample database, or we can select a backup of one of our currently running databases. I'm going to select the sample database. The only ones available are AdventureWorks, so I will stick with that. We need to choose a server to place our databases on. Now, in Azure terms here, the server is simply a container for placing databases. You cannot configure anything in your server other than its name and which data center you wish to put it in. It is not like a traditional server where there is lots of options to configure. It is literally just the container we want to use. So I'm going to put it in my North Europe data center on a server that already exists. We need to provide the server login name, which cannot be admin, and the password. We then need to choose what power level we wish to give it. I will talk a bit more about power levels in a minute, but there are various power levels available to us, all costing different amounts of money. I'm going to stick with the basic one because that's all I need for this, which incidentally is £3 a month. Bargain if you need a simple small database for managing for whatever purpose you wish to use it for. So I will select the basic. Collation, I can't actually choose a collation here because I've chosen a sample database, so I'll get that database. I'll get that collation from there. Click Create, give it a few minutes, and we will have a brand new database for us to install, for us to connect to and start placing our data in. And there we have it online. Here is our database DB1. If I click on DB1, we can see all sorts of information and configuration options that are available to us to make our database work the way we want. Now if we want to connect to our database using Management Studio, now that we've created it, we need to do two things. First of all, we need to find out the connection string that we need to use in Management Studio to connect to it, and we also need to give the Azure firewall, we need to configure the Azure firewall to allow connections from our computer to Azure. So the connection strings, if you're anything like me, you can never remember a connection string for your application. Azure allows you to connect using ADO, ODBC, PHP and JDBC, and you can simply copy that connection string out and place it into your application. So that's fairly straightforward stuff. And also we need to configure the firewall rules to allow our Management Studio to connect to our database. The firewall rules are held at the server level in the portal. So if I click on the server, we can now click on Show Firewall Rules. And here we have a list of the IP addresses that are currently allowed to connect to Azure. When you build a database, nothing can connect. You have to give permissions to it. It has no permissions whatsoever. One nice feature is, rather than you having to try and work out where your IP address is, you can simply click that button and it will add my current IP address to that list, and then I can save it. If you want other Azure services to connect with your Azure database, you have to click on this option, allow access to other Azure services, so that those services are allowed through. Otherwise, your Azure web app or whatever will not be able to see your database. So now we've assigned an IP address, we can go over to Management Studio and we can connect to our database. So let me select server, and there it is. So you just put in the server name .database.windows.net, 1433. Currently, Azure SQL Database only supports SQL Server authentication. You cannot connect using Active Directory. It is coming. It is in private preview. By the end of the year, you will probably be able to connect to an Azure SQL Database using your Azure Active Directory linked to your on-premises Active Directory. But for the moment, we must log in using SQL authentication. Here we go. Now, the first thing you're going to notice that there are a lot less options than traditional SQL, which is what we have up here. There are only two options, database and security. Most notably, there is no SQL agent. There is no integration services, high availability, and all the rest. You must remember that Azure SQL Database is a database as a service. All this is offering us is somewhere to place our tables, our views, our procedures, and our data. If you want things like scheduling, Azure has numerous options for scheduling and automation, which you can create and link to your Azure SQL database. Azure SQL Database is just a database as a service. To connect to an Azure SQL Database Management Studio, you require Management Studio 2012 and above, but I would highly recommend that you have 2014 Service Pack 1 or 2016 as I have here. I have Management Studio 2012 running here, and here are the tables of my AdventureWorks database. If I right click on a table, you will see that there are no GUI options that you are used to. 2012 does not provide any of the GUI options when you're connecting Management Studio to an Azure SQL database. If you use 2016, you'll find options are much closer to what you're used to seeing. So if I expand AdventureWorks and go to tables, you'll see that I get the options that you're used to seeing: a designer, select and edit, etc. However, logins, if you're hoping to use a GUI to create a login with Azure, if I click on new login, you'll see that I only get some T-SQL. I do not get a GUI. You're going to have to write code if you wish to create logins and a few other bits and pieces. So let's load up my SQL script and let's have a look and see what sort of things we can do. So, useful thing, AT version. What do we get with AT version? Always handy to see. There we are, Microsoft Azure RTM version 12. So it's SQL 2014 compatible at the moment. If we want to create a database, we can simply say create database DB1. That's all that you have to do, and that will go off and create a database. If we want the full syntax, create database, collation, and then we can say maximum size, the addition that we wish to have, the power rating that we mentioned before, and the left sub-level within there. There is no option for recovery model or compatibility. That does not exist because you're always in full recovery model and the latest compatibility, as we'll see in a moment. You can also make a copy of a database. So just simply say create database 3 as copy of one of your existing databases, and it will go and check. We can also see the status of our database by running this command here, and it will tell us the state. So this one is now online, but if you were creating a large copy, you could run that and you could actually see how far it's got. Now the first thing which you're going to find really annoying is that the use command does not work. As you can see here, the use statement is not supported to switch between databases. You cannot do it. If you want to change it, you must select it from the drop-down list. So if we go to DB1, we can now select the database property, and we get the addition, which is the standard addition, as we mentioned before. If I go back to master, and this is a bit of a pain that once you've moved away from master, you cannot get the drop-down to work. I could change that database very quickly if I decided I don't need as much power as a standard database gives us. I can get away with the basic just by running modify and modify the addition, and it's done it. So let's go back to DB1 again, and let's just have a look at some of the parameters. So DB1, it's always online, it's always in full recovery mode. It's got a compatibility of 120, you can't change that. The collation that I've already selected, it's always in multi-user mode. I'm not sure you can change that, and we're in snapshot isolation state. If we want to create users, it's the same. It's a very similar syntax to what we have with traditional SQL, but we cannot select things like, we cannot put in things like default database, default language, or expiration. None of those options will work. All it is create user login with whatever the password is, and then create the user from that. Do watch out though, if you say right click and script as, I'm sure many of you have used that option, you will find that it will script it out as if it's a traditional SQL database with those options. So you will need to be very careful when you're writing any T-SQL if you use the scripting options within Management Studio to strip out any of the stuff to do with that doesn't apply with SQL Azure. Server roles in Azure are completely different. There are only two. There is DB Manager, which allows people to create databases, and there is Login Manager, which allows people to manage logins. When you build a new server, there is an account called the owner, which is the account that I've been using to log in, and that has both of those roles that allow me to drop and create databases. Database roles haven't changed. They're all in there. Some new rules that you will need to get used to is firewall rules. You saw me create a firewall rule through the management portal. That is a server level firewall. You can also do it at the using T-SQL as well, and these here are the commands. So we have set SP set firewall rule, which is a server level firewall rule, and we also have set SP set database firewall rule. How it works: if you have a server level firewall rule that lets you in, then you can connect to any database on that server. If you're not in the server level firewall rule but you're in the database level firewall rule, then you'll only get to just that database. Server firewall rules you can set from within the GUI. Database rules you can only set using T-SQL. So you will need to watch out for that as well. So that gives you a flavor of some of the T-SQL commands. Let's nip back over to PowerPoint. And let's make most of it. That's what I want. So just to summarize, there's a limited GUI with 2012 and 2014 RTM. Try and use a later version of Management Studio. You're going to have to start writing some code. Watch out for the Azure syntax. You can't use the use command in any of your code, so that could cause a few issues if you're scripting, and you will have to use the new commands for managing firewall rules. There are limitations to Azure, so there are some unsupported features such as extended properties, anything to do with the agent and MSDB because it doesn't exist, anything related to database file placement, file size, file locations, they no longer exist. Which a lot of DBCC commands are no longer there because you don't have access to the master database file stream. As you can see, you can't have linked servers, global temporary tables, and you can't shut down a server. You can turn off a database from the portal, but you can't shut down a server. Do watch out for old documentation if you are reading on the limitations. The previous Azure version 11 had a lot of restrictions, which have now generally been removed. Now going back to our service level, we mentioned before, there are 3 performance levels within Azure: Basic, Standard and Premium. And each service tier has several different power levels in them, and these are measured in something called a database transaction units. Used to be database throughput units, but Microsoft have changed the name, so I have noticed. A DTU represents the power of the database as a mixture of CPU, memory or disk configuration. Unlike your traditional SQL Server, you cannot choose the number of CPUs, the memory or the disk layout. You do not have that choice anymore. You can simply decide the number of DTUs you want to have. And I think the reason for this difference is to avoid people trying to compare an Azure database to a traditional database and saying, well, if I have this many and this many and they're the same, they don't work the same. In this way, come up with a different power rating. You can't actually compare anything. So just to give you a bit more details, you can see Basic, Standard and Premium. So Microsoft description of these is: a basic is best suited for small database size, supporting typically one single active operation at a given time, such as for the development or testing or small-scale infrequently used applications. Standard is the best option for most cloud applications, supporting multiple concurrent queries such as workgroup and web applications. Premium is designed for high transactional volume, supporting a large number of concurrent users and requiring the highest level of business continuity. And for each service tier, you'll see there is a maximum size: basic 2 gig up to premium P11 of 1 terabyte. The DTU numbers that you can see there allow you to see the relative power the relative power of the different performance levels. So basic has 5 DTUs, so you can expect S1 with 20 DTUs to have 4 times the power of basic. Similarly, P1 is 12.5 times more powerful than S0. You decide on the power level you think you require. You can then monitor and tune the database as required. As you've seen, it's very easy to change from one tier to another if you decide you need more or less power. Remember, you set the power level at the database, not at the server, and that can sometimes be a bit confusing. When it comes to backups and high availability, such as mirroring and replication, this is all taken care of for you. Backups are automatically created for every active database. Full backups once a week, differential backups at least once a day, and transaction log backups every 5 minutes. The full and differential backups are copied to a partner region, in our case the other European data center, to ensure availability of the backups in the event of a disaster in the primary data center. Additionally, it maintains multiple copies of the database in different physical locations in the primary data center to mitigate outages due to hardware failure. At any one time, 3 database replicas are running, 1 primary and 2 secondary. Data is written to the primary, 1 secondary synchronously, and to the second asynchronously. If the hardware fails on the primary, the database fails over to the secondary replica seamlessly. In the case of a complete loss of a replica, a new one is automatically created. So there are always, at a minimum, 2 physical, transactionally consistent copies of your data in the data center. And you don't have to do anything to manage it, it's all done for you. You can also set up your own replication to another data center, and this is called geo-replication. If you have a standard database, you can have 1 read-only secondary in another data center. If you have premium, you can have 4 read-only secondaries in different data centers all over the world. But be careful, you do pay for those extra secondaries. They will cost you the same price as your primary database. So if you have a P11 at 50,000 a year, 4 read-only secondaries, that's another 200,000, that's $250,000 a year. It's getting quite expensive. So as you can see, log shipping, mirroring and always on type functions are all taken care of for you. When it comes to restoring, all databases have the option of point-in-time restore. So you can restore at any time you like because they're all in full recovery mode. You cannot overwrite an existing database. You can only restore to a new database on the same server. And be warned, backups are not kept for that long. Basic for only 7 days, standard are kept for 14, premium are kept for 35. If you need to keep backups for longer than this, and you can't access those backups to download and store elsewhere, they are not accessible. If you need to keep backups for longer periods, then you'll have to take your own backups using an option called automated export, which currently is only in the classic portal. In the event of a major failure of the primary data center, then you can use Geo Restore to bring up your database using one of those backups that has been copied over in the partner region. As you can see, the recovery time can be quite a while. If you have geo-replication set up, you can fail over or break the mirror at any time you like, and it comes up pretty fast with very little loss of data, which might be a better option for you if you want that. While we're on backups, as we said, you can take your own backup files. You can take your own backups using automated export, or there is a backup button on the portal as well for one-off backups. And this will create backups in Azure Blob Storage. Now, Azure does not use traditional backup files. You cannot use .back files to restore or back up your Azure database. There's a new type of backup file called a backpack, which is more like an installation script than a traditional backup. And the term is an extract or an export data tier application. So a backpack is a copy of the schema plus the data. And this is used as a backup to create new databases. Unlike traditional backups, you cannot use backpacks to restore over the top of an existing database. There's also another option called DACpack, with just a copy of the schema. These aren't supported in Azure, but you should be aware of them. You can actually use DACpacks as a way of upgrading databases from UAT to prod. The database can read the DACpack, see the difference between UAT and prod, and apply the schema changes. And this is something worth having a look at if you're not aware of what's going on. If you have Management Studio, if we quickly flip back to Management Studio, if you have a traditional database as we have up here, if I click on a database such as my AdventureWorks on my local disk and I right click and go to tasks, you may have seen these options before and wondered what they were. These are where you are creating your DACpack. So we can deploy a database straight to Microsoft Azure, straight to an Azure virtual machine, or we can export our data to create a backpack on our local disk, which we could then copy up to our blob storage and then use that to create a new database. If you haven't seen those options or wondered what they were, that is what they are for. So let's go back over to Azure. Let's look up my SQL database. Again, let's use my AdventureWorks database this time on my North European data center. If we scroll down here, here's the geo-replication that we mentioned. If I click on here, we get a new blade opening up on the right hand side, and we can simply say I want to replicate my database to the West European data center. Simply click on there, choose the pricing tier, select a already existing Azure SQL Server to place our database on, and then click OK, and that will now start replicating. It's a small database, so it shouldn't take too long, and you can see the pretty little diagram showing that it is now replicating quite happily. Let's scroll back over here. Let's have a look at a couple more options. There are a lot of options here, too many to discuss in the time available. This one here in the middle is a tiny little graph which doesn't really do justice to what is available. Microsoft are collecting numerous metrics on your Azure database. Here's an idea of the list that there are. It's collecting information like how many times someone has been blocked at the firewall, the CPU percentage, the DTU percentage, how many failed connections, successful connections, the database size, all sorts of options available which are all being collected on here. Unfortunately, this tiny little screen doesn't really give you a good idea of what's being collected. But one of the nice features in Azure, in the new portal, is that you can create your own dashboards. And here I've created a dashboard showing 4 metrics which I'm interested in, so we can see the database size over the past week has been going up and down. I have some automated jobs, reading and writing, inserting and deleting. We can see the CPU going up and down. We can see the number of successful and failed connections, not very many today by the looks of it, and we can see how many people have tried to hack into my system and have been blocked by the firewall, which fortunately is none. They'd be wasting their time because it's just AdventureWorks anyway. Another nice feature is this alert rules over here. We can actually set up an alert, so if one of our metrics breaks a certain threshold, it can email you. So I have one here set up called hacking attempt, which basically says the metric is blocked by firewall. If I get more than one blocking in the last 5 minutes, then email the owner, or a semicolon list of email addresses. So you can then see if your CPU is getting too high. If you've had lots of failed connections, you can be alerted to that information, and that is quite nice to do and could be very useful to you. Now, if Azure SQL database doesn't meet what you're after, if platform as a service is not what you are after, you can create virtual machines in Azure, a virtual Windows server with SQL Server installed, and you can then connect to it using RDP just as you would in your own office. Microsoft provide more than just SQL and Windows, as you can see from this list. We do have Windows Server, but we have Red Hat Linux, we have Ubuntu, all sorts of things which I'm not always sure exactly what they are. And here we have SQL Server and on Windows, and we can have anything from 2008 Enterprise all the way down to SQL Server 2016, which is currently released candidate, will become the main one. We also have Oracle on Windows, Oracle on Linux. It's all available here. You can build your own server and then connect to it, but you are now using that server. You will start becoming responsible for the software on it, the upgrades and the like, and the licensing, so you need to watch out for that. A couple final points if we nip back to our display. A few things that you may want to be aware of. Something new coming up is Azure Elastic Database. We've only talked about databases in isolation with a certain power level that you need to monitor and increase or decrease as you need. Not always that easy and could get expensive. What Microsoft are offering with Azure Elastic Database is the ability to put a pool of databases together that all share a certain number of DTUs. The idea being that when one is busy, it will use up more of the DTUs, where one is quiet, and hopefully they will then go up and down and balance out, which might make more economic sense for you if you have a whole series of databases. They can share a larger number of DTUs than you would normally have. Hopefully that shared amount will then balance. Azure Data Warehouse, if you're looking for large data analysis services types features, Azure Data Warehouse can offer this to you. This is based on the massive parallel processing architecture. And there's also Azure Data Lake, a hyperscale Hadoop repository for unstructured and structured data, which you may find useful. And finally, you're going to hear a lot of people talking about on-prem, on-premise, on-premises. I cringe every time I hear someone say on-premise, because that is not anything to do with a building or property. It actually means a proposition or assumption. So if you don't take anything else away from my presentation today, please say on-premises. If you have to use that expression, don't say on-premise, because it's just bad English. So in conclusion, I hope you have found this useful. that you now have a better understanding of SQL Azure. If you want to talk to me, that's my email address. Read Gethin's blog. You can get hold of me on LinkedIn. And of course, don't forget my ebook. Thank you very much for listening, and I hope that you can use some of this.